Dear students, in this video I am going to discuss branch and bound technique. Fine. This is the second method to find the integer solution of a given linear programming problem. So let us explain to explain this method. Let us take a problem. Maximum z is 3x1 plus 4x2 subjected to 7x1 plus 16x2 less than equals to 52. 3x1 minus 2x2 is less than equal to 9. x1 x2 is greater than equals to 0 and integer. So this is the problem. Fine. So now to apply branch and bound technique, basically we need to apply a graphical method. Fine. And this method will work in two dimension. So that's why we have taken a two-dimensional problem. So now first we will not consider this integer restriction. We will remove this integer restriction and get the solution with the help of graphical method. So now from the first constraint, put x1 0. So what we will get? We will get 52 by 16. 52 by 16. That means this point 0, 13 by 4. Fine. Similarly, put x2 0. So we get 52 by 7. So this point 52 by 7 0. Join these 2 points. So this is the first constraint. And region is less than equal to 0 because 0 0 will satisfy this. Fine. Similarly, second constraint is this. Put x2 0. So we get x1 is equal to 3. That means this point. And when put x1 0, so we get x2 is minus 9 by 2. So somewhere here, somewhere in the negative axis. When you join this, so we will get this constraint. So this is the second constraint. This is the second constraint. Intersect x2 axis, this x2 axis in the negative direction. Fine. So this will be the region because 0 0 will satisfy this. And since x1 x2 is greater than equal to 0, so x1 is greater than 0, x2 is greater than 0. So ultimately this is our feasible region. Fine. Now when you apply when you draw this objective function, then you will see that optima reaches as x1 is 4, x2 is 3 by 2 and maximum z is 18 with the usual graphical method. So this is the solution. But you will see that here x2 is not in integer. Here x1 is an integer, this is an integer, but this is not an integer, not an integer. This is an integer, but this is not an integer. Fine. So now our aim is to find out the integer solution. That means x1 will be integer and x2 should be integer. So how to find out this solution? So here we will do the branching and then we will find out the bounds. So that's why the name of the method is branch and bound. So to get the solution, this is our initial solution. x1 is 4, x2 is 3 by 2 and maximum z is 18. That means this solution. And the point is here B. Point is B. So now we will do the branching. Branching is done corresponding to the variable which is not an integer. For example, here x2 is not an integer solution. So we will do the branching corresponding to x2. If both are not integer, then you can take the integer to take the variable which is having largest fractional part. Here the fractional part is half, but here is this is already an integer. So there is no need to take largest fractional part. So since this is the only variable which is not an integer, so take it. So now we will use x2 as a branching variable. So here if you will see, what is x2? x2 is in between 1 and 2. So here is 1, here is 2. And somewhere here is 3 by 2. This 3 by 2. So branching is done in this region. That means x2 is less than equals to 1 and this region. That means x2 is greater than equals to 2. Fine. So x2 is less than equal to 1 and x2 is greater than equal to 2. So here we will divide this part into two parts. One is x2 is less than equals to 1 and another is x2 is greater than equals to 2. So this will be the procedure. Fine. That means we are introducing a third constraint, x2 is less than equal to 1 and x2 is greater than equal to 2. So let's see. Apply this approach herein. So this is the graph. So now draw the graph. One is x2 is less than equal to 1. So x2 is less than equal to 1 is this. This is 1. So here draw this. So we get this. x2 is less than equal to 1. So this intersects, this constraint intersects this region at this point. What is the point? This point is say denoted by say this point is denoted by say I D. This point is denoted by O. This is A, B, C, and this is point D. This point is D. So this intersect this at the boundary D. Similarly, next is x2 is greater than equal to 2. So x2 is greater than equal to 2 is here. This will be the upper one area. So this intersects this boundary at this point, and this is denoted by say E. Now find the point D. D is the intersection of this line 2 and this line. So this will be the point. This will be the point 11 by 3 and 1. Similarly, if the coordinate of point A is 20 by 7 and 2, which is the intersection of first constraint and this line. So you can solve and get the solution. So now here we will draw this argument here, that solution is x1 is equals to is 11 by 3, x2 is 1 and z is 15 and point is D. Here the solution is x1 is 20 by 7, x2 is 2 and z is 116 by 7 and the point is E. Fine. So we have done this, and now this part is removed. We will not consider this part. Fine. So this will be we will not consider this part. This is cancel out. We will not. So we will consider only this part and this part. Fine. Now here you will see that now x2 is an integer, but now x1 is not an integer. Similarly here x2 is an integer, but x1 is not an integer. So again do the branching in two parts. Now x1 is 11 by 3. So branching will be done corresponding to x1. Fine. So here what is x1? x1 is 11 by 3. That means 11 by 3. This can be written as, this is will be 3 plus this will be somewhere 3 plus some 2 by 3. Fine. This is the value. So here, so that's why branching will be done as x1 is less than equal to 3 and x1 is greater than equals to 4, because the value is laying in between 3 and 4. So the area will be this and this. So x1 is less than equals to 3 and x1 is greater than equals to 4. So again we have these two nodes. Let's see. So here x1 is less than equal to 3 and the area is this one, point D. That means this one, area is this. So now draw this, x1 is less than equal to 3, that means this. So just draw the line. This will be the less than equal to 3, and another is x1 is greater than equal to 4. That means this point. So when you draw this will intersect here, and you will see that this is not feasible. Not feasible because outside the region. So that's why this is infeasible. And so branching is not done further. Here the solution is this point. This is the boundary point. This is the region. This is the region. This is the region. So here is the boundary. This point is denoted by, say, EF, DEF. So point is F, and the coordinate is here. This is 1, this is 3. So 3, 1. 3, 1. So the coordinate is x1 is 3, x2 is 1, and z is here 13. Z is 13 and point is F. Fine. This is infeasible. So since both are integers, so no branching is done further. क्योंकि दोनों इंटीजर आ गए तो आगे ब्रांचिंग नहीं करेंगे. फाइन. नाउ here is we get x1 is 20/7, so branching is done. So here x1 is in between 7, this is 20/7. So here is 2, here is 3, somewhere is 20/7. So branching is done either in this region or in this region. So here x1 is less than equal to 2 and x1 is greater than equal to 3. Fine. So here is we get node, here is another node. So let's see. X1 is less than equal to 2 and the region is this, because this is the region, point E region. So this is the region. So here x1 is less than equal to 2. So less than equal to 2 means this part. This will intersect the curve here. And this is the greater than equal to 3. So greater than equal to 3 is this. And again this is infeasible. This is infeasible. Infeasible. So this will be the infeasible. Outside the region. However here this is the point. This is the point. Boundary point. Uppermost value, because we are finding the maximum value. Maximum value will come here. So the point is here, which is x1 is, this point will be x1 is 2, x2 is 19/8 and z is 31/2. So this is, call it as G point. G. This is Z, 2 and 19/8. So here this is not an integer solution, so branching will be done further. Fine. So let's see. Here is branching. So here x2 is less than equals to 19/8. So less than equal to 2 and x2 is greater than equal to 3. Fine. So when less than equals to 2, so what we will get? So here we are getting this region. So now x2 is less than equal to 2. That means this is 2. So this region. That means we will move on the boundary. We will move on the boundary. We will exactly into this. This says that we have to move here, but this new constraint says that we have to move here. So that means we will on the boundary. तो हम बिल्कुल boundary पे चलेंगे. तो जब हम boundary पे चलेंगे और region है ये वाला हमारा, so the solution will be at this point. This point, because we have already moved here. Because x2 is, this x1 is less than equal to 2 region. We are moving here and here. This is already infeasible. So we are not considering this part. So we will not consider this part because our branching is this. Due to this factor, so we will not consider this part. Fine. So here the boundary is, the solution is this point 2, 2. So x1 is 2, x2 is 2 and z is here 14. This is denoted by point, say h. So point is h. Point is h. Fine. Now here x2 is greater than equal to 3. x2 is greater than equal to 3 is this point. So just draw the picture here. So this will intersect the graph at this point. So what is the point here? HI, I point, and the coordinate is 4 by 7 and 3. So this will be x1 is 4 by 7 and x2 is 3 and z is 96 by 7, which is approximately, which is equals to 13.71. Fine. Now you will compare both these solutions. Here the value is 14, here the value is 17.1. That means less than this point, this value. So when at the same level, both are at the same level, but at the same level, when one gives the larger value and another one gives the smaller value, then this type of node is known as fathomed node. Fathomed node. जब एक ही लेवल पे एक नोड ज़्यादा वैल्यू दे और इवन इंटीजर वैल्यूज दे और दूसरा जो है हमें इंटीजर सॉल्यूशन ना दे और वैल्यू भी कम दे, सो दिस वैल्यू 13.71, दिस इज 14, तो इसकी वैल्यू भी कम है और इंटीजर भी नहीं है. सो दिस टाइप ऑफ नोड इज कॉल्ड फैथम्ड नोड और इसमें नो फर्दर ब्रांचिंग is required. Fine. So this is all about the branch and bound technique. Now find out the solution. So we get integer solution here. x1 is 2, x2 is 2 and z is 14. Another integer solution is this. Here x1 is 3, x2 is 1 and z is 13. So among these two, the optimum solution is this. This is the largest one. Here is 13, here is 14. So the solution is this point h. H gives the optimum solution. And solution is x1 is 2, x2 is 2 and z is 14. This is the solution. So this is all about the branch and bound technique. I hope you understand. So this is all about your syllabus. Fine. So now your syllabus is complete. Fine. Thank you.